This section is about the graphs of sine and cosine functions. The essential question for this unit is, how do you sketch the graphs of sine and cosine functions? This figure shows the graph of the sine function, or also referred to as the sine curve. Now you'll notice if you start with x equals 0 and go to the right until x equals 2 pi, you have one cycle of the sine curve. But the sine curve extends infinitely far to the left of 0 and infinitely far to the right of 2 pi. Now this figure here shows the graph of the cosine function, or also known as the cosine curve. And if you look from x equals 0 out to x equals 2 pi, you have one cycle of the cosine curve. Now, as you might remember, the domain of the sine and cosine functions is a set of all real numbers. So therefore, x can equal anything. So this graph keeps going farther to the right of 2 pi. It also keeps going infinitely far to the left of 0. And that the range of the function for both cosine and sine is from -1 to 1. So the maximum value is +1, the minimum value is -1 for both sine and cosine. Another thing to note here is that typically when we're graphing either sine or cosine, the x-axis is in radians as opposed to degrees. So most of the time you're going to see these graphs with the x-axis in radians, and obviously the y-axis will just simply be the amplitude. Now some key points whenever we're graphing either sine or cosine would be the intercepts, the maximum points, and the minimum points. The intercepts are simply where it crosses the x-axis. For the cosine curve, you'll notice that it crosses the x-axis at at pi over 2 and 3 pi over 2. And the maximum points occur at x equals 0, it's +1, and x equals 2 pi, it's +1. And the minimum point occurs at x equals pi, where it's -1. So those are the key points in graphing either sine or cosine. Now let's say we had general forms of the equation for sine x and cosine x. So I have y equals a sine x or y equals a cosine x. The amplitude of these two functions is half the distance between the maximum and minimum values of the function, and it's given by the amplitude is equal to the absolute value of a. Now this is true for either sine or cosine. So in the graph above for y equals cosine x, in that case a is simply equal to 1, and as you can see, the amplitude, which is half the distance between the min and the max, is equal to 1. So the amplitude is equal to the absolute value of a, whatever that coefficient is in front of sine x or cosine x. Now, obviously, if a is greater than 1, say a is 3, then we would basically stretch the cosine or sine function, and instead of going up to 1, it would then go up to 3 and down to -3. And if a was only equal to 1/2, we would shrink the sine or cosine function, and that means that it would only go up to 1/2 and down to -1/2. So depending on what a is, you can either stretch it or shrink it. Now, if we would generalize the functions a bit further and say now we have y equals a sine bx, where b is some constant number, or y equals a cosine bx. Now, so a represents amplitude, and now we got some constant times x, some b. Then we can talk about the period of the function. Remember, the period is one cycle of the function. So again, in either case, whether we're talking sine or cosine, the period would simply be 2 pi divided by whatever that value is for b. So period would equal 2 pi over b. And again, depending on the value of b, whether it was greater than 1 or less than 1, would determine whether you are horizontally stretching or shrinking the function. So obviously, if b were less than 1, then the period, say b was equal to was equal to 1/2, then the period would equal 4 pi, and you would be stretching it horizontally. Whereas if b was equal to 2, then the period would only equal pi, and you would be shrinking it horizontally. So let's take our general function or equation one step further and say now we have y equals a sine parentheses bx minus c, or y equals a cosine parentheses bx minus c. Again, a is amplitude, deals with amplitude. B determines your period. Now what about this constant value c? Well, this basically introduces phase shift, okay? So that means phase shift to either the right or the left. So phase shift in this case, where the graph is shifted either to the right or to the left, is equal to c over b. So whatever the value is of c divided by whatever the value is of b, and that'll determine your phase shift. So lastly, our general equation now looks like y equals a sine parentheses bx minus c plus d, or y equals a cosine bx minus c parentheses plus d. Now what does that d do? That d basically translates it vertically. So if d is a positive number, it shifts it up so many units. If d is a negative number, it shifts it down so many units. So now let's look at an example. Let's say we want to sketch the graph of y equals 3 cosine 2x plus 2. Well, in this case, a is equal to 3, b is equal to 2, and d is equal to 2 as well. So let's see what this graph might look like. So now remember what the basic cosine function looks like. And now let's see what's happened to this. Well, first thing we notice is that the amplitude is 3. So notice it no longer goes up just to 1. It now goes all the way up to 3 on the y-axis and down to minus 3 on the negative y-axis. Also notice that we have a phase shift. We have a phase shift equal to pi over 2. Okay, again, based on the fact that we got cosine of 2x. That we've got a plus 2 on the end there. And also notice that the period is equal to pi, again because of the 2x, the fact that b is equal to 2. So it's 2 pi over b, or 2 pi over 2, which means the period, therefore, is equal to pi. So this graph, y equals 3 cosine 2x plus 2, looks basically like you see in the figure below. So once you have determined what the period and amplitude is for y equals minus 3 cosine 2 pi x, post your answers in the drop box.